Welcome to Chemazon-Complete Chemistry. So in this video, we are going to learn the concept of chemical shift in NMR. Okay, so let us understand the concept of chemical shift with this small story or analogy. Okay, imagine a small kid with a very large umbrella. Okay, and the rain is going on. So this child is not getting wet. Okay, and it is happy. So basically, what is chemical shift? Chemical shift okay, it is basically frequency, and what is its unit? It is ppm. Okay, it is a measure of frequency. Okay, frequency at which proton resonates. So what does this chemical shift depend on? It depends on the magnetic field experienced by the proton. Magnetic field experienced by the proton. If in 1H NMR it will depend on proton, in any other heteronuclear NMR it depends on that particular nuclei. So what does this magnetic field depend on? It depends on the electron density. Okay, it depends on the electron density around the nuclei or proton. So what you can do is you can imagine this rain as the magnetic field. Okay, and then you can imagine this umbrella as the electron density. And this boy as the proton or the nuclei. So if the electron density is more, what will happen? The magnetic field magnetic field means the rain. Okay, it is not experiencing that much rain because it has a larger electron density, or we can say larger shield. Okay, so that is why such protons which have a greater electron density, okay, such protons which have a greater electron density, they are called as shielded. They are called as shielded protons. Okay, so the electron density experienced by the proton is less. The electron density is more. Okay, that is the umbrella is larger, and since the electron density is more, what will happen? The rain or the magnetic field experienced is less. Okay, the magnetic field experienced is less. So since the magnetic field experience is less, the chemical shift or change in frequency will also be less. Okay, chemical shift will be less because it depends on the magnetic field experienced by the proton. Magnetic field is less, so chemical shift will also be less. Okay, so let us understand with one small example. For example, there is some methyl group that is attached to another carbon atom. Okay, CH2CH3 methyl group. So for this proton, okay, for this group of proton, that is CH3, adjacent to this you have a less electronegative. Okay, less electronegative atom. Okay, so this is called as a shielded group of proton. Okay, the CH3 is called as shielded group of proton, and since it is shielded, what will happen? It will experience less magnetic field, and hence the chemical shift will be lower. Okay, now let us understand another example where this boy, okay, that is again the proton 1H, and it has very less electron density, that is it has a smaller umbrella. So now you can see what is happening? The electron density is less. The electron density is less, so what will happen? It is getting wet and it is sad. Okay, so you can see it is getting wet, that means it is experiencing greater magnetic field. Okay, it is experiencing greater magnetic field, and since it is experiencing greater magnetic field, the chemical shift value will be higher. Okay, the frequency value will be higher. Okay, what is the example of this type of proton? Again, let us take the example of CH3, okay, and OH. Now here, if you see this H, okay, this proton, it is directly attached to a electronegative atom. Electronegative atom means it will withdraw electron density around hydrogen towards oxygen, because it is more electronegative. So we call this proton as a de-shielded nuclei. Okay. In the literal meaning of shield means some protection or cover. What is the meaning of shield here? It is the electron density. If the electron density is more, as we saw in the earlier case, it is called shielded nuclei, or the phenomena is called shielding. And here the electron density is less, so it is called de-shielded nuclei, and the phenomena is called as de-shielding. Okay, in the next, in the coming slide, we'll also see there are several names for this, like de-shielding. This is also called as downfield downfield, and the shielding one is called as upfield. Okay, so let us understand with the help of one example. Now, these three green protons that you can see, okay, all these three methyl groups, they are attached to what? They are attached to a less electronegative carbon atom. Right, this methyl is also attached to carbon, this methyl is also attached to carbon. So these 9 protons, they are called as what? They are called as shielded protons. Shielded protons or shielded nuclei. Whereas if you see this one, the brown one, this methyl is directly attached to an electronegative oxygen atom. So what it will do? It will withdraw electron density from this brown methyl group. Okay, so this is called as de-shielded proton. De-shielded protons. Okay, so if you see what is an NMR spectrum, okay, NMR spectrum, it is a plot of, okay, it runs like this. Okay, this is lower value, and as we go on the left, it is higher value. So on the y-axis, it is the intensity of proton. Okay, it is the intensity, and on the x-axis, it is what? It is a chemical shift. On the x-axis, what is plotted? Chemical shift. Okay, what is the symbol of chemical shift? Chemical shift symbol is delta. Okay, and what is a unit? Unit is parts per million or hertz. Okay, it is basically frequency. Okay, now what does this intensity depend on? Okay, so first let us understand the value of chemical shift. For the green protons, where will be the chemical shift? Will it be higher or lower? The answer is they are shielded, so they will experience lesser magnetic field. Okay, and so its value will be lower. Okay, so peak will come like this. And for the brown one, okay, for the brown one, where it will come? For the brown one, it is de-shielded, so it will experience greater magnetic field, so the chemical shift will be higher. Okay, and what does the intensity depend on? That is very, very important concept. The intensity of the peaks is directly proportional to the number of hydrogens or nuclei present in one particular group. Okay, number of hydrogens present in a group. So in the green one, you can see there are how many protons? 3 plus 3 plus 3, 9 protons. So the height of the green one, let's say it is 9 centimeter. Okay, just a rough value. Then it is a relative. Okay, the height is relative. This is 9 protons, the height will be this much. Then in the brown one, you can see here there are how many protons? There are 3 protons. So the height will be lower. Okay, so this is 9, so this will be 1/3. Number of protons is also 1/3. So this will be, let's say, 3 centimeters. So very important, there are two things. One is a chemical shift, that will see some examples we will see in the next slide. What are the factors that affect the chemical shift? Okay, and the another important thing is the intensity. Okay, or this is also called as the integration. Okay, when you get the peak, you do the integration. Okay, that is you find out the area under the curve. Okay, that we'll see in detail what is the meaning of this in the coming videos. Okay, so integration, from integration you get the number of protons, and the intensity depends on the number of protons in one particular group. Okay, so now let us see the actual spectrum. So you can see here the green one, 9 protons, you can see the height is higher, okay, and the chemical shift value is lower because it is shielded, whereas the brown one you can see the chemical shift value is greater and the height is lower. Okay, this is for 1H spectrum. Similarly, for 13C NMR spectrum also the same rule is followed. Now this carbon, the red one, you can see it is closest to the most electronegative oxygen atom. So you can see the peak of this red one, it is here. Okay, it is most de-shielded. Then the orange ones, orange one you can see 1 and 3, they are here, they are shielded. Okay, then the brown ones, they are more far away from the oxygen atom. Okay, and you know, as the distance increases, the inductive effect also decreases. So the chemical shift value of the brown one is even lower than the orange group of protons, and the green one you can see it is the farthest from the oxygen atom. So it is, we can say it is shielded protons. Okay, so that last carbon, green carbon, the peak is here, that is it is shielded. Okay, and you can see the difference in the chemical shift. Okay, chemical shift values in 1H ranges from 0 to 12 ppm. Okay, it is lower, whereas for carbon 13C you can see the range of chemical shift, it ranges from 0 to 220 ppm. Okay, we'll see this reason. What is the reason for this, the chemical shift being higher? The one reason is that the 13C, the abundance, okay, the isotopic abundance of the 13C is lower. Okay, lower, that is a percentage of amount of 13C available in nature is less. Plus the another reason for this is that the gyromagnetic ratio is 1/4, is 1/4. Okay, the major reason being it the abundance, okay, the isotopic abundance of 13C is lower. Okay, so that is why the range of the chemical shift is higher. Okay, now let us understand what is the formula for chemical shift. The observed frequency downfield from the TMS. So the NMR spectrum that we draw, we assume one value to be 0. Okay, which is that value? 0 is for TMS. TMS is the standard. What is the full form of this? Tetramethylsilane. Okay, silane means methane is carbon with 4 bonds. Silane is silicon with 4 bonds. Okay, silicon also belongs to carbon family. Tetramethyl means there are 4 methyl groups. Tetra means 4. Okay, so this is the reference standard. Okay, or you can say internal standard. Okay, it is the internal standard that is used in NMR. Okay, so this value you can see it is highly shielded. There are 12 methyl groups. Okay, so it is highly shielded and it is used, its value is assumed to be 0 ppm. Then we go to the left, the chemical shift value increases. Okay, so let us understand this with the help of an example. Okay, one numerical. Calculate the chemical shift of absorption that occurs at 1500 Hz downfield from TMS using 300 MHz NMR spectrometer. So what is the formula for chemical shift? Is the shift or observed chemical shift in Hertz. Okay, shift, observed chemical shift from the TMS, this value is in Hertz, divided by the instrument frequency. Okay, the operational frequency of the instrument, NMR instrument. Operational frequency of the instrument. This is in megahertz. Okay, so this is 10 raised to 6. So the value that you will be getting is it in the power of 10 raised to minus 6. That is nothing but part per million. Million means 10 raised to 10 to the power of 6. Okay, so what is the value? The unit will be ppm. So the shift is 1500 hertz divided by NMR instrument frequency is 300 megahertz. So 300 ones are 5s are, the answer is 5 ppm. So in this way you can calculate the value of chemical shift if you have given the frequency that is downfield from the TMS and the the frequency of the instrument. Okay, operational frequency of the instrument in megahertz. If both these values are given, you can convert. You can find the value of the chemical shift in ppm. Okay. Now there are different names for the chemical shift. Now chemical, if you talk in terms of chemical shift, see from left to right the value increases. So on the right hand side initially it is small, as you go to the left we say it is large chemical shift. For the field, if you talk in terms of field, initially it is high or upfield, and the magnetic field, the field if you talk on the left hand side it is called downfield or low. Okay, it is called downfield for if we go on the left, and initially it is high or upfield. Similarly frequency, initially it is low, as we go on the left it is high. And shielding we saw just now, lower chemical shift value it is called shielded nuclei, and higher chemical shift value it is called deshielded nuclei. Okay, so these are some of the different terms when we talk about the chemical shift. Okay, another example of chemical shift values. So this green carbon, this is attached to a sp3 hybridized carbon. Here the percentage S character is how much? It is 25%. Whereas for sp2 hybridized carbon, the percentage S character is how much? 33.3%. And we know the electronegativity is directly proportional to the percentage S character. So that is why the hydrogen that is attached to sp3 hybridized carbon, its chemical shift value ranges from 0 to 5 ppm, that is shielded. Whereas that of hydrogen attached to sp2 hybridized carbon, this is from 5 to 10 ppm, that is deshielded. Okay, another example is the electronegativity of these groups. Fluorine is maximum electronegativity 4, hydroxyl is less, chlorine is lesser, bromine less, and iodine is least. Similarly, if you see CH3F, okay, the chemical shift of this methyl value they have given, fluorine is most electronegative, the chemical shift value, since fluorine is most electronegative, the methyl will experience, it will have least electron density, so it will experience maximum magnetic field. Okay, it will experience maximum magnetic field, and hence it is going to be deshielded. OH is less electronegativity, so you can see the chemical shift value is decreasing. Okay, because the electronegativity is decreasing, so the electron density around the methyl is increasing. Okay, electronegativity is decreasing from left to right. So what is happening? The electron density, it is what? Electron density is increasing. Since the electron density is increasing, what will happen? Magnetic field experience will be lesser. Okay, remember rain as the magnetic field. Okay, so magnetic field will be lower, so the chemical shift value or delta also decreases. Okay, let us see one more example. Now if you see CH3 proton, okay, methyl, Here you can see carbon is attached to, okay, let us first talk about methane, okay, where there are all 4 hydrogens. Now if you replace one of the hydrogens with carbon, now as compared to hydrogen and carbon, which is more electronegative, carbon is more electronegative. So the chemical shift value of methyl will be higher. Now from methyl, if you replace one more hydrogen with carbon, then what will happen? The electronegativity will increase slightly more. So the magnetic field experience will be greater because the electron density is decreasing. And when you replace one more carbon, that is called methine. CH3 is methyl, CH2 is methylene, and CH is methine. Okay, here there are 3 carbons. Most de-shielded, so the electron density is minimum. So the magnetic field experience will be maximum. So the chemical shift value is also maximum. Example, see CH3 methyl, there is only one carbon, so the chemical shift is lowest. Here also CH3 methyl proton, it is lower, whereas methylene protons, here you can see there are 2 carbons. Okay, so the value is higher. Then one more example, the carbon closest to electronegative atom is most de-shielded, so magnetic field experience is maximum, chemical shift will also be maximum. And as we go far away from this carbon, beta carbon, it is lower, chemical shift is lower, gamma it is even lower, and delta carbon it will be least because the inductive effect experience will be minimum. So the magnetic field experience will be minimum, it is shielded, so the chemical shift value is lower. Now these are some of the very important chemical shift values that you have to remember. So this is tetramethylsilane that we assume it as a reference or the internal standard. We assume that value to be 0. Then we saw just now methyl, methylene and methine. You can see methine it is maximum, methyl it is lowest, because in methine there are 3 carbon atoms, 3 electronegative carbon atoms, so the value is higher. Then allylic carbon, here we saw it is closer to the double bond. Okay, there is another concept called diamagnetic anisotropy, because of which the chemical shift value of some of the protons like vinylic protons, okay, and aldehydes, okay, especially carbonyl compounds, aldehydes and ketones, and the aryl, okay, these are higher because of a concept called diamagnetic anisotropy that we'll see in the next videos. Okay, so these are some of the values. The carbon next to carbonyl, this is very important, you have to remember it is around between 2 to 2.5 or 2 to 3. Then aromatic methyl, it is 2.4 to 2.7. Okay, these are some of the values that you can remember. And very important, hydrogen are directly attached to oxygen, that is going to be 2.5 to 5, or mostly it is found it is around 4 to 5 ppm. Okay, now the values being more difficult to remember, so you can remember the values by this pictorial representation. Okay, 0 to 1.5 saturated compound will show chemical shift, 1.5 to 2.5 the allylic and the carbon attached to carbonyl group. Then the carbon that is attached to oxygen or halogen, that will show value between 2.5 to 4.5. Then vinylic, that is directly attached to sp2 hybridized carbon, that will show 4.5 to 6.5. Aromatic protons, okay, directly attached to the benzene ring, they will show, generally they show the chemical shift around 7 ppm, that you can remember, very important, 7 ppm. Okay, and carbonyl compounds show the maximum chemical shift value, the aldehydes, ketones and carboxylic acid between 9 to 12. Okay, similarly you can remember these values for the 13C NMR. Here also the carbonyl shows the maximum chemical shift value between 160 to 220. Okay, and lowest is 0 to 60, it is methyl, methylene and methine, and the carbon attached to halogens. Then nitrogen and oxygen, carbon attached to nitrogen and oxygen, the value ranges from 50 to 80. Then carbon-carbon triple bond, it is 80 to 100. Then 100 to 150. Carbon-carbon triple bond, carbon-carbon double bond, and aromatic protons. Okay, so basically this is also called as the alkene region. Okay, where you see the peaks of carbon attached to double bond. Okay, either it is aromatic double bond or aliphatic chain double bond, nitriles, and the carbonyl will show maximum chemical shift value. Okay, that's it for this video. I hope you have understood some of the very important peaks. First, what is chemical shift? Okay, what does it depend on? It depends on the magnetic field experienced by the proton, okay, by the nuclei. And what does that depend on? It depends on the electron density. Okay, I hope you have understood with that example of that kid being the proton, umbrella being the electron density, and rain being the magnetic field. Okay, you can imagine very easily. Then you should also remember the formula. Okay, formula for chemical shift. Many times they ask numericals in 1 or 2 marks numerical in JAM exam. Okay, they have also asked in GATE exam. We'll solve previous year questions. Okay, where they have asked, they have given frequency values and they will ask you the value of chemical shift either in ppm or in hertz. Okay, how do you convert ppm to hertz? You multiply it by the operational frequency. If you multiply by the operational frequency, you will get the answer in what? Answer in hertz. Okay, it's basically we have done cross multiplication. Chemical shift is shift in hertz divided by the operational frequency in megahertz. Okay, then third thing, we also saw some of the very important examples, how the electronegativity of the adjacent carbon or adjacent atom, how does it affect the electron density, and then it eventually affect the value of chemical shift. Okay, then another important concept that you have to remember is the intensity of proton. What does the intensity of proton in NMR spectrum depend on? It depends on the number of hydrogens present in one particular group. Okay, I hope you have understood all these concepts, very important. And in the next video, we'll see two things. One is how to count the number of 1H NMR and 13C NMR signals. Okay, they will give you the structure of the compound and they will ask you to count the number of 1H and 13C NMR signals. Second, okay, we'll also see the very important concept of splitting pattern. Okay, so in the NMR spectrum, you will not see straight lines. Sometimes you will see, but mostly you see splitted signals like this. Okay, so how does the splitting pattern takes place, that we'll see. And one more very important concept, that is the concept of coupling constant. Okay, factors affecting coupling constant. These are the concepts that we'll see in the coming videos. I hope you have understood this video. Thank you.